welcome to another episode of Whispering Wikipedia. Today we are doing something a little bit different from the norm, and we are reading 2 Wikipedia pages. Now, I've been requested to read both the Cobra and the Rattlesnake. Now, upon taking a look at the Cobra Wikipedia, I've seen that it is really quite short, and so I thought I can do these 2 related videos in one, so I hope that you like it. Now, if you have anything you would like me to read about on Wikipedia, please tell me in the comments below. I read every comment. I can't always read every reply, but I do read every single initial comment, so please suggest something for me to read so I can keep this series going. Without any further ado, please remember I cannot pronounce scientific names or terminology. Let's get into this Wikipedia. Starting with the Cobra. Cobra is a common name of various elapid snakes, most of which belong to the genus Naja. Biology. All of the known cobras are venomous, and many are capable of rearing upwards and producing a hood when threatened. Other snakes that are known as cobras, all members of the Naja, the true cobras, can rear upwards and produce hoods when threatened. Other cobra genera species are as follows: the ringled or ring-necked spitting cobra, so called for its neck band as well as the habit of rearing upwards and producing a hood when threatened. The king cobra or hemidryad, the 2 species of tree cobras, the Goldie's tree cobra and the black tree cobra. The 2 species of shield-nosed cobras, the Cape coral snake and the shield-nosed cobra. The 2 species of the black desert cobras or desert black snakes, Walter Inicea aegyptia and Walter Inicea morgani, neither of which rears upwards and produces a hood when threatened. The eastern coral snake or American cobra, Micrurus fulvius, which also does not rear upwards and produced a hood when threatened. The false cobra, Hydrodynastes gigas, is the only cobra species that is not a member of the Elapidae. It does not rear upwards, and it produces only a slight flattening of the neck when threatened and is only mildly venomous. You can see why I chose to make this episode have 2 Wikipedia pages. Now we are on to the Rattlesnake, which goes a lot further in depth. Now, rattlesnakes are a group of venomous snakes of the genera Crotalus or Cisterus, of the subfamily Crotalinae, the pit vipers. The scientific name Crotalus is derived from the Greek, meaning castanet. The name Cisterus is the Latinized form of the Greek word tail rattler, and shares its root with the ancient Egyptian musical instrument, the sistrum, a type of rattle. The 36 known species of rattlesnakes have between 65 and 70 subspecies, all native to the Americas, ranging from southern Alberta, Saskatchewan, and southern British Columbia in Canada. to central Argentina. Rattlesnakes are predators that live in a wide array of habitats, hunting small animals such as birds and rodents. Rattlesnakes receive their name from the rattle located at the end of their tails, which makes a loud rattling noise when vibrated that deters predators or serves as a warning to passers-by. However, rattlesnakes fall prey to hawks, weasels, king snakes, and a variety of other species. Rattlesnakes are heavily preyed upon as neonates, while they are still weak and immature. Large numbers of rattlesnakes are killed by humans. Rattlesnake populations in many areas are severely threatened by habitat destruction, poaching, and extermination campaigns. Rattlesnakes are the leading contributor to snakebite injuries in North America. However, rattlesnakes rarely bite unless provoked or threatened. If treated promptly, the bites are seldom fatal. That's good to know. On to the ecology, range and habitat. Rattlesnakes are native to the Americas, living in diverse habitats from southwestern Canada to central Argentina. The large majority of species lives in the American Southwest and Mexico. 4 species may be found east of the Mississippi River and 2 in South America. In the United States, the states with the most types of rattlesnakes are Texas and Arizona. Rattlesnakes are found in almost every type of habitat, capable of supporting terrestrial ectothermic vertebrates, but individual species can have extremely specific habitat requirements, only able to live within certain plant associations in a narrow range of altitudes. Most species live near open, rocky areas. Rocks offer them cover from predators, plentiful prey, e.g. rodents, lizards, insects, etc., that live amidst the rocks, and open basking areas. However, rattlesnakes can also be found in a wide variety of other habitats, including prairies, marshes, deserts, and forests. Rattlesnakes prefer a temperature range between 80 and 90 degrees Fahrenheit, which is 26 and 30 degrees centigrade, but can survive temperatures below freezing, recovering from brief exposure to temperatures as low as 4 degrees Fahrenheit, which is negative 16 degrees Celsius, and surviving for several days in temperatures as low as 37 degrees Fahrenheit, which is 3 degrees. They sound like very hardy creatures. The most probable ancestral area of rattlesnakes is the Sierra Madre Occidental region in Mexico. The most probable vegetation or habitat of the ancestral area appears to be pine oak forests. Feeding habitats play an important ecological role by limiting the size of rodent populations, which prevents crop damage and stabilizes ecosystems. Moving on to prey. Rattlesnakes consume mice, rats, small birds, and other small animals. They lie in wait for their prey, or hunt for it in holes. The prey is killed quickly with a venomous bite, as opposed to constriction. If the bitten prey moves away before dying, the rattlesnake can follow it by its scent. When it locates the fallen prey, it checks for signs of life by prodding it with its snout, flicking its tongue, and using its sense of smell. Once the prey has become is then ingested head first, which allows wings and limbs to fold at the joints in a manner which minimizes the girth of the meal. That's so clever. The gastric fluids of rattlesnakes are extremely powerful, allowing for the digestion of flesh as well as bone. Optimal digestion occurs when the snakes maintain a body temperature between 80 and 85 degrees Fahrenheit, which is 25 to 29 degrees centigrade. If the prey is small, the rattlesnake often continues hunting. If it was an adequate male, the snake finds a warm, safe location in which to coil up and rest until the prey is digested. Onto hydration. Keep hydrated. Rattlesnakes are believed to require at least their own body weight in water annually to remain hydrated. Annually. The method in which they drink depends on the water source. In larger bodies of water, streams, ponds, etc., they submerge their heads and ingest water by opening and closing their jaws, which sucks in the water. If drinking dew or drinking from small puddles, they sip the liquid either by capillary action or by flattening and flooding their lower jaws. That's cute. I don't know if I've seen a snake drink before. I think I've seen them flick water with their tongues, but I don't know about drinking. Moving to predators. Newborn rattlesnakes are heavily preyed upon by a variety of species, including ravens, crows, roadrunners, raccoons, opossums, skunks, coyotes, weasels, whip snakes, king snakes, and racers. Neonates of the smaller crocodile species are frequently killed and eaten by small predatory birds such as jays, kingfishers, and shrikes. I don't know the last one. Some species of ants in the genus Formica are known to prey upon neonates, and Solipsis invicta, fire ants, likely do as well. On occasion, hungry adult rattlesnakes cannibalize neonates. The small proportion, often as few as 20% of rattlesnakes that make it to their second year, are heavily preyed upon by a variety of larger predators, including coyotes, eagles, hawks, owls, falcons, feral pigs, badgers, indigo snakes, and king snakes. I didn't know feral pigs hunted snakes. I'm not sure if I ever want to see a pig crunching down on a live snake. The common king snake, Lampropeltis catula, a constrictor, is immune to the venom of rattlesnakes and other vipers, and rattlesnakes form part of its natural diet. Rattlesnakes sense king snakes' presence by their odor. When they realize a king snake is nearby, they begin enacting a set of defensive postures known as body bridging. Unlike its normal erect and coiled defensive striking posture, the rattlesnake keeps its head low to the ground in an attempt to prevent the king snake from gaining a hold on it. The head being the first part of the rattlesnake to be ingested. The rattlesnake jerks its body about while bridging its back upwards, forming an elevated coil which faces the king snake. The elevated coil is used to strike the attacker and is also used to shield the head from the king snake. Interesting. Moving on to the anatomy of the rattlesnake. Sensory organs. Like all pit vipers, rattlesnakes have two organs that can sense radiation. Their eyes and a set of heat-sensing pits on their faces that enable them to locate prey and move towards it, based on the prey's thermal radiation signature. These pits have a Aside from their eyes, the rattlesnakes are able to detect thermal radiation emitted by warm-blooded organisms in their environment. Functioning optically like a pinhole camera eye, thermal radiation in the form of infrared light passes through the opening of the pit and strikes the pit membrane located in the back wall, warming this part of the organ. Due to the high density of heat-sensitive receptors innervating this membrane, the rattlesnake can detect temperature changes of 0.003 degrees Celsius or less in its immediate surroundings. Infrared cues from these receptors are transmitted to the brain by the trigeminal nerve, where they are used to create thermal maps of the snake's surroundings. Due to the small sizes of the pit openings, typically these thermal images are low in resolution and contrast. Interesting that they use the terms resolution and contrast when talking about real life image quality. I thought that would be only a digital thing. That's interesting. Nevertheless, rattlesnakes superimpose visual images created from information from the eyes with these thermal images from the pit organs to move more accurately and visualize their surroundings in low levels of light. Research conducted recently on the molecular mechanism of this ability suggests the temperature sensitivity of these pit organs is closely linked to the activity of transient receptor potential and CRIN1, a temperature-sensitive ion channel saturated in the pit membrane. An ion channel is basically like a nerve, and messages are communicated via an action potential, which is kind of almost like a wave which moves along the outside of the membrane and is kind of activated or helps to activate these little channels where different types of ions like sodium go in and out of a cell. Moving to eyes. Rattlesnake eyes, which contain many rod cells, are well adapted to nocturnal use. However, rattlesnakes are not exclusively nocturnal, and their vision is more accurate during daylight conditions. Rattlesnakes also possess cone cells, which means that they are capable of some form of color vision. The rattlesnake eye lacks a fovea, making it impossible for them to see sharply defined images. Instead, they mostly rely on the perception of movement. Rattlesnake eyes are capable of horizontal rotation, but they do not appear to move their eyeballs to follow moving objects. Smell. Rattlesnakes have an exceptionally keen sense of smell. They can sense olfactory stimuli both through their nostrils and by flicking their tongues, which carry scent-bearing particles to the Jacobson's organs in the roof of their mouths. Auditory system. Like all snakes, rattlesnakes lack external ear openings, and the structure of their middle ear are not as highly specialized as those of other vertebrates, such as mammals. Thus, their sense of hearing is not very effective, but they are capable of sensing vibrations in the ground passed by the skeleton to the auditory nerve. No need to tease the snakes about their ineffective sense of hearing. Fangs. Rattlesnake fangs are connected by venom ducts to large venom glands near the outer edge of the upper jaw towards the rear of the head. When the rattlesnake bites, muscles on the sides of the venom glands contract, which squeeze the venom through the ducts and into the fangs. When the fangs are not in use, they remain folded against the palate. That's creepy, so they're like this, but when they need them they go kind of like a vampire, but I don't know, I mean, some vampires the teeth goes me, and other vampires the teeth is always there. fangs every 6 to 10 weeks. At least 3 pairs of replacement fangs lie behind the functioning pair. Wow, I wonder why they shed their fangs so frequently. Maybe they break or something. Interesting. Venom. The venom is hemotoxic, destroying tissue, causing necrosis and coagulopathy, which is disrupted blood clotting. In the US, tiger rattlesnakes, sea tigers, and some varieties of the mojave rattlesnake, C. scolotus, also have a presynaptic neurotoxic venom component, which is known as mojave type A toxin, which can cause severe paralysis. So, neurotoxic and presynaptic. I'll just quickly explain that. So, in your nerves, to get from one nerve to another, you use something called a neurotransmitter. It's just a little chemical that kind of goes from one to another. When you have depression, you have problems with these neurotransmitters, so you get a drug called SSRI, which basically helps you keep them more. Serotonin. So it lets you keep your serotonin so you can properly use your brain. Now, a neurotoxic venom would mean that the venom actually destroys that. So they're similar to the nerve agents that Russia has been using to poison people. And when it says presynaptic, a synapse or synaptic area is basically where it's the junction. It's a synaptic junction where the end of one of the tentacles of the nerve connects to another of the tentacles, and presynaptic means it's before that junction. So that means that their venom goes in and then destroys the transmitter before it even can go to the next one. And thus that's why, it causes paralysis, because to be able to communicate to your muscles, you have to send a signal along your nerves. And you can't do that if the signal can't move from one nerve to another. That's why, in severe cases, like with Russian poisoning, people get paralysis or they even stop breathing because, their pathways which communicate to breathe stop working. So there you go. That's how, that's a synaptic cleft and a synaptic area. Although it has comparatively low venom yield, the venom toxicity of sea tigers is considered to be among the highest of all rattlesnake venoms and among the highest of all snakes in the Western Hemisphere, based on LD50 studies conducted on laboratory mice. C. scolotus is also widely regarded as producing one of the most toxic snake venoms in the Americas, based on LD50 studies in laboratory mice as well. Rattlesnake venom is a mixture of 15 enzymes, various metal ions, biogenic amines, lipids, free amino acids, proteins, and polypeptides. It contains components evolved to immobilize and disable the prey, as well as digestive enzymes which break down the tissue to prepare for later ingestion. It's very interesting. As we read before in the normal snake Wikipedia, the venom seems to have been an evolved version of saliva. I find it super evolutionarily interesting and so effective that, if you're a predator, just biting someone with your saliva itself makes them go into paralysis and starts the digestion process of their muscles, so you can just slurp them up. That's crazily both intimidating but also so effective, and it makes so much sense. The venom is very stable and retains its toxicity for many years in storage. Older snakes possess more potent venom, and larger snakes are frequently capable of storing larger volumes of it. Now, to the bit that you all have been waiting for, and I know I have been, the rattle. The rattle serves as a warning for predators of the rattlesnake. The rattle is composed of a series of hollow interlocked segments made of keratin, which of course is the fingernail hair rhino horn stuff, which are created by modifying the scales that cover the tip of the tail. The contraction of special shaker muscles in the tail causes these segments to vibrate against one another, making the rattling noise, which is amplified because the segments are hollow in a behavior known as tail vibration. The muscles that cause the rattle to shake are some of the fastest known, firing 50 times per second on average, sustained for up to 3 hours. Dang. At birth, a pre-button is present at the tip of the snake's tail. It is replaced by the button several days later when the first skin is shed. However, no sound can be made by the rattle until a secondary segment is added when the skin is shed again. A new rattle segment is added each time the snake sheds its skin, and the snake may shed its skin several times a year, depending on food supply and growth rate. That's very interesting, so every time it seems. So I guess you can kind of tell its age by looking at the size of the rattle, but then it also says that it depends on food supply and growth rate, so maybe it's not that accurate. That's interesting. Rattlesnakes travel with their rattles held up to protect them from damage, but in spite of this precaution, their day-to-day activities in the wild still cause them to regularly break off end segments. So it's a little bit like a fingernail or something, and they hold it up so it doesn't break off. Interesting. Because of this, the age of a rattlesnake is not related to the number of rattles on its tail. Interesting. So that's why it has to keep replenishing itself, because the end breaks off, because it's made of keratin, and it needs to keep being produced. Very interesting. One of the differentiating features of males and females is the males have thicker and longer tails because they contain inverted hemipenes. Also, the tails of males taper gradually from the body, whereas the tails of females narrow abruptly at the vent. When you look at sexual dimorphism versus male versus females in almost all species, usually the keratin production is a bit more hardcore in males because of the impact of testosterone. This is one of the reasons why dudes kind of get thicker nails and a little bit thicker eyelashes and hair. So of course you remember the classic jealousy that girlfriends get of their boyfriends when they look at their eyelashes and go, "It's so unfair, why do boys get longer eyelashes?" It's biological mainly. Also, interestingly, I don't mean this in a metaphorical sense, but physically males have 25% thicker skin. And it's small differences in sexual dimorphism like that. When you're talking about, biological gender, that I find super interesting. Because just the very subtle implementation of a hormone at the right time can have such an interesting and profound and long-lasting effect on the overall, impact of a body. Very interesting how a little drug can do so much. Okay, skin and circulation. Rattlesnakes, like other members of the Squamata order, contain a circulatory system that is powered by a 3-chambered heart composed of 2 atria and 1 ventricle. The right atrium receives a deoxygenated blood from veins coming from the systemic circuit. The left atrium receives oxygenated blood from the lungs in the pulmonary circuit and pumps it to the ventricle and through protection from varieties of threats including dehydration and physical trauma. The typical rattlesnake genus Crotalus has the top of its head covered with small scales, except with a few species, a few crowded plates directly over the snout. The skin of snakes is highly sensitive to contract, tension, and pressure. They are capable of feeling pain. An important function of the skin is the sensation of changes in air temperature, which can guide the snakes toward warm basking shelter locations. All snakes are ectotherms. To maintain a stable body temperature, they exchange heat with their external environments. Snakes often move into open, sunny areas to absorb heat from the sun and warmed earth, a behavior known as basking. Nerves in the skin regulate the flow of blood into veins near the surface. The skin of a rattlesnake is intricately patterned in a manner that camouflages them from their predators. Rattlesnakes do not generally have bright or showy colours, e.g. reds, yellows or blues, instead relying on subtle earth tones that resemble the surrounding environment. That's not good for us, seeing as they are venomous. Creases in the epidermal tissue connect the scales of rattlesnakes. When ingesting large prey, these creatures can unfold, allowing the skin to expand to envelop a much greater volume. The skin appears to tightly stretch to accommodate the meal, but in reality, the skin is simply smoothing out from its creased state and is not under very high tension. Now on to reproduction. Most rattlesnake species mate during the summer or fall, while some species mate only in the spring or during both the spring and fall. Females secrete small amounts of sex pheromones which leave a trail. The males follow using their tongues and Jacobson's organs as guides. Once a receptive female has been located, the male often spends several days following her around, a behaviour not common outside of the mating season, frequently touching and rubbing her in an attempt to stimulate her. The males of some species, such as timber rattlesnake, C. horridus, fight each other during the mating season in competition over females. These fights are known as combat dances, consisting of the two males intertwining the anterior portion of their bodies, often with their heads and necks held vertically. The larger male usually ends up driving the smaller males away. Although many kinds of snakes and other reptiles are oviparous, meaning they lay eggs, rattlesnakes are oviviparous, giving birth to live young after carrying eggs inside. The female produces the eggs, in her ovaries, after which they pass through the body cavity into one of her two oviducts. The ova are arranged in a continuous chain in a coiled section of the oviduct known as the tuber. Male rattlesnakes have sexual organs known as hemipenes located in the base of the tail. The hemipenis is retracted inside of the body when mating is not occurring. The hemipenis is similar to the human penis. Females can store semen for months in internal recesses known as spermathecae, which permits them to mate during the fall, but not fertilize the ova until the following spring. The Arizona black rattlesnake, C. Origanus cerberus, has been observed to exhibit complex social behavior reminiscent of that in mammals. Females often remain with their young in nests for several weeks, and mothers have been observed cooperatively parenting their broods. That's interesting. Rattlesnakes generally take several years to mature males usually reproduce only once every 3 years. Moving to brumation. In the colder winter months, some rattlesnake species enter a period of brumation, which is dormancy similar to hibernation. They often gather together for brumation in large numbers, sometimes over 1,000 snakes, huddling together inside underground rattlesnake dens or hibernacula. Rattlesnakes regularly share their winter burrows with a wide variety of other species, such as turtles, small mammals, invertebrates, and other types of snakes. Rattlesnakes often return to the same den year after year, sometimes travelling several miles to get there. It is not known exactly how the rattlesnake find their way back to the dens each year, but may use a combination of pheromone trails and visual cues, e.g. topography, celestial navigation, and solar orientation. Species with long periods of brumation tend to have much lower reproductive rates than those with shorter brumation periods, or those that do not brumate at all. Female timber rattlesnakes in high peaks in the Appalachian Mountains of New England reproduce every 3 years on average. The lance-headed rattlesnake C. polysticus, native to the warm climate of Mexico, reproduce annually. Like most other snakes, rattlesnakes aestivate during very hot and dry periods, which is why they are rarely seen during the hottest and driest months of summer. On to conservation status. Rattlesnakes tend to avoid developed areas, preferring undisturbed natural habitats. Rapid habitat destructions by humans, mass killings during events such as rattlesnake roundups, and deliberate extermination campaigns all pose threats to rattlesnake populations in many areas. Several species of rattlesnakes, such as the timber rattlesnake, Mesozoa, and cannebrake rattlesnake, are listed as threatened or endangered in many U.S. states. Many rattlesnakes die from being run over by cars. In more heavily populated and trafficked areas, reports have been increasing of rattlesnakes that do not rattle. This phenomenon is commonly attributed to selective pressure by humans, who often kill the snakes when they are discovered. Non-rattling snakes are more likely to go unnoticed, so survive to reproduce offspring that, like themselves, are less likely to rattle. And that's how evolution works. Moving on to safety and first aid. So, you know what to do when one of them bites you. Rattlesnakes are the leading cause of snakebite injuries in North America and a significant cause in Central and South America. Avoiding bites. Rattlesnakes tend to avoid wide open spaces where they cannot hide from predators, and generally avoid humans if they are aware of their approach. Rattlesnakes rarely bite unless they feel threatened or provoked. A majority of victims, about 72%, are males, often young and intoxicated. Around half of the bites occur in cases where the victim saw the snake yet made no effort to move away. Caution is advised even when snakes are believed to be dead. Rattlesnakes' heads can sense, flick the tongue, and inflict venomous bites reflexively for up to an hour after being severed from the body. Wow. Effect of bites on humans. An estimated 7,000 to 8,000 people are bitten by venomous snakes in the United States each year, with about 5 deaths. The most important factor in survival following a severe envenomation is the time elapsed between the bite and treatment. Most deaths occur between 6 and 48 hours after the bite. If anti-venom treatment is given within 2 hours of the bite, the probability of recovery recovery is greater than 99%. When a bite occurs, the amount of venom is injected in under voluntary control by the snake. The amount released depends on the variety of factors, including the condition of the snake, e.g. having long, healthy fangs and a full venom sac, and its temperament. An angry, hungry snake that has just been stepped on versus a satiated snake that was merely surprised by walking near it. About 20% of bites result in no envenomation at all. A lack of burning pain and edema 3/8 of an inch, 1 centimeter away from the fang marks after 1 hour suggests no or minimal envenomation occurred. A lack of edema or erythema in the area of the bite after 8 hours indicates a lack of envenomation for most rattlesnake bites. Common symptoms include swelling, severe pain, tingling, weakness, anxiety, nausea, vomiting, hemorrhaging, perspiration, and rarely heart failure. Local pain following envenomation is often intense, increasing with ensuing edema. Children generally experience more severe symptoms because they receive a larger amount of venom per unit of body mass. On to anti-venin. Anti-venin, often referred to as anti-venom, is commonly used to treat the effects of local and systemic pit fighter envenomations. The first step in the production of crystalline anti-venom is milking the venom of a live rattlesnake, usually from the western diamondback, Crotalus atrox, eastern diamondback, Crotalus adamantus, South American rattlesnake, Crotalus durisus terrificus, or the Verdulace Bothrops actros. The extracted venom is then diluted and injected into horses, goats, or sheep, whose immune systems produce antibodies that protect from the toxic effects of the venom. These antibodies accumulate in the blood, which is then extracted and centrifuged to separate the red blood cells. The resulting serum is purified into a lyophilized powder, which is packaged for distribution and later used by human patients. Because anti-venom is derived from animal antibodies, people generally display an allergic response during infusion known as serum sickness. On to veterinary care. In the United States, more than 15,000 domesticated animals are bitten by snakes each year. Rattlesnake envenomations account for 80% of the deadly incidents. Dogs are most commonly bitten on the front legs and head. Horses more generally receive bites on the muzzle, and cattle on their tongues and muzzles. If a domesticated animal is bitten, the hair around the bite should be removed, so the wound can be clearly seen. The crystalline fab antivenom has been shown to be effective in the treatment of canine rattlesnake bites. Symptoms include swelling, slight bleeding, sensitivity, shaking, and anxiety. Now, lastly, seeing them in human culture. First, in spirituality. Indigenous Americans. Aztec paintings, Central American temples, and the Great Burial Mounds in the southeastern United States are frequently adorned with depictions of rattlesnakes, often with the symbols and emblems of the most powerful deities. The feathered serpent, or Mesoamerican religion, was depicted as having the combined features of the Quetzal and rattlesnake. The ancient Maya considered the rattlesnake to be a vision serpent that acted as a conduit to the other world. Rattlesnakes are a key element in Aztec mythology and were widely represented in Aztec art, including sculptures, jewelry, and architectural events. Christian snake handling sects. Wow, I didn't even know that was a thing. Members of some Christian sects in the southern United States are regularly bitten while participating in snake handling rituals. Snake handling is when people hold venomous snakes unprotected as part of a religious service inspired by a literal interpretation of the Bible verses Mark 16:17-18, which reads, "In my name they will pick up snakes with their hands." I've never heard of that. As food, journalist Alistair Crook claimed that rattlesnake tastes just like chicken, only tougher. Others have compared the flavour to a wide range of other meats, including veal, frog, tortoise, quail, fish, rabbit, and even canned tuna. Methods of preparation include barbecuing and frying. Author Maud Newton, following a recipe by Harry Crews, described the taste. At least when breaded and fried like a sinewy, half-starved tilapia. Wow. Now, the very last tiny bit. Symbolism. The rattlesnake became a symbolic animal for the colonials during the Revolutionary War period and is depicted prominently on the Gadsden flag. It continues to be used as a symbol by the United States military and political movements within the United States. What a crazy and interesting Wikipedia that was. Thank you so much to whoever suggested me to read that one. There was so much random and interesting stuff. That Christian sect that handles venomous snakes. That's crazy. Never heard of that. And also, I just find it so interesting that, as we read in the snake Wikipedia, that the venom actually comes from their saliva, and because they want to get up and eat something, the instinct is to attack it and eat it, and the venom helps to break it down. It's crazy. Super interesting. Thank you so much for watching this video. I hope that you had a good pause, a good rest, a good reprieve, and